Hey everybody, welcome to Houdini Hangout. It is Wednesday the 14th of February. It's Valentine's Day, so happy Valentine's Day to everybody out there. I know some people do more, do less for Valentine's Day. You know, it's one of those interesting holidays that's very divisive. But yeah, here we are. Hopefully, if you are spending it with us, we'll hopefully get some cool results in Houdini tonight and play around with some things. Hey, John, welcome to the stream. Welcome. So if you saw any of the announcements for, from socials or anything like that, tonight we're going to be doing something a little different than I normally do. I'm going to be doing a couple of not short, but a couple of updates to some stream information. Hey, Chris, welcome to the stream. Nice to have you. I know it's late for you. I think you're over in the UK there. Hey, La Pampadura, welcome. So yeah, we're going to be doing a couple of updates to the stream, or to things that we've done recently. In fact, in the last two streams, I have things that I want to update, which doesn't happen all that often, but I've learned some things and realized how kind of brain dead I was being in the last stream. So we're gonna have some updates that we can do to kind of maybe help everybody get a little bit better understanding. Yeah, exactly. Never too late to learn something. For sure, yes. Both for you being over in the UK, and for me, never too late after I've streamed this stuff to go back and learn something. Um, so yeah, so that's the idea for the stream this evening, and I think hopefully it'll be a cool, hopefully it'll just kind of close the loop on some information that we put, that I put out there or whatever. And yeah, so that's the idea. That's what we're going to be doing tonight. So, and then I think after that, exactly. Yeah. Yes. Learning something new your whole life. That is for sure the theme. So yeah, and that's why I do this stream, is to connect with folks and be able to both learn and help other people learn and all that kind of stuff. So here we are. But after we do these updates, if there's a little bit of time at the end, which I'm kind of guessing there will be, we'll kind of just open it up and see if anybody has any questions or thoughts or anything that they've been wondering about or trying to figure out. So, we can play around with some things and do whatever. And then maybe if I don't figure it out, the end of this update will prompt more updates. I don't know. I'm just thinking. But yeah, I mean, and as always, there's, comments, questions, thoughts, anything that you might have, that to kind of add to this conversation would obviously be welcome. And, hey, Enkeet, welcome. That's an interesting question. John's just asking a question here about coming up with cool ideas to make. That's an interesting question. I mean, for me, if I'm looking to do something abstract or different, a lot of times what I'll do is start some sort of an inspiration board for myself that I kind of just store things on, to look at in the future, to kind of pull from. And that often gives me a starting point personally, like when I've had to, I'm not really in the world of having to do a lot of, final creative stuff and things, like full projects and things like that. But when I am trying to do stuff like that, oftentimes I'll look back at inspiration boards things that I've found that are interesting looking or had some sort of interesting movement or creative direction or things like that. And often I try to find things that aren't motion graphics related. That's a lot of times what I do, in order to, to get some inspiration and things like that. So, I like websites like Colossal and, different creative websites that have, art and design and things like that I can pull from when I'm thinking of doing motion graphics and, just kind of abstract and creative things. So oftentimes that's where I go. And yeah, obviously, PureRef is a great thing once you've got that reference to kind of bring it in and have it, in your workspace in a place that you can have be able to kind of reference as you're doing things. But so yeah, maybe that'll answer your question a little bit. Hey, Zach, how's it going, man? Welcome. Everybody kind of has different ways of kind of finding inspiration, I think. And for me, that's always been something interesting, is looking at things outside of the design, the animation world particularly. I mean, sometimes I'll try to recreate things that I've seen, and I do that a lot on the stream here, where I see something and I'm like, let's recreate that or break it down or figure out how it's done. But yeah, hopefully that kind of answers your question, and there are no dumb questions here. So yeah, glad to be able to maybe help you out a little bit there, give you some thoughts. Yeah, that's a great point too, La Pampadura. Yeah, I think I think that a lot of trying to recreate things helps you really learn the technical side of things. I think if you're interested in trying to do something that you've seen somebody else do, kind of reverse engineering it helps you to learn some of those processes as well. So yeah, for sure. Hey, hi Tom. I can see you're still at work. It's what, 6 o'clock? Yep, 6 o'clock. Still working away. Tom single-handedly ruining the side effects work-life balance. I'm sure he's not the only one there, but welcome to the stream, Tom. Glad to have you. He never leaves. Tom never leaves the office. Well, there you go. So if you ever need anything, just ping Tom. Apparently he'll be at the office. If something's broken on the side effects website, maybe he can kick a server or something for you. Anyways, yeah, and Keith, I think that's a great point too, that you find inspiration in places that you don't often expect, and that's a good thing to keep in mind. But anyways, yeah, great little kind of introductory chat there. Obviously, nice little thing to think about, and it's always, you're always kind of looking for where to find inspiration. So hopefully that, hearing mine and other people's responses to that might be helpful to you. But yeah, just kind of branching off what John had kind of said there. He's like, he said he has a dumb question, but I don't like to say that there are any dumb questions. And personally, like, I think people have questions, and if you're not understanding something, it's better to ask for clarity than just sit there and go, well, I guess I should have known how to do that. So there's not, never going to be any question shaming here or anything like that. Might say, well, this is, whatever, but there's not going to be any dumb questions here. So bring them on, anything you might want to ask. And in fact, if you have any suggestions for me on how I could be doing things better in the scenes, always helpful as well. Because if we can make the corrections while we're doing this, then the stream is better. In fact, when Henry's around a lot of times on the Mops Mondays things, he's always given me little tips and things like that as we're going. So, because I'm relatively new at using Mops, so it's a little bit of me learning and you guys learning as well. So, yeah, that's always super helpful, and I appreciate any feedback while we're doing this. So, I think with that, we'll get in and start doing some Houdini stuff and kind of see where the evening takes us. But like I said, I've got two things to cover first. So the first one I'm going to cover is the one that's really easy, not really easy, but is a simple thing to update and just kind of give everybody some stuff. So let's jump over to Houdini and get started. So, so we were talking about value clips. So we were talking about value clips a couple weeks ago, maybe a week or two ago. And while pretty much everything I said is totally good, I did run into some issues with one thing in particular. And so if you're doing the let me just kind of resize this a little bit. So just to kind of, let's get everybody back on track here to this project. This is the value clip project and procedurals. We were talking about USD procedurals or Husk procedurals. When we were talking about that, we also talked about value clips a little bit. And this is just a simulation here. It's just a sim of Flippy animating. Actually, is this, why is that not importing? Let's take a look here. Because that is not pointing at the right spot. So let's see here. Yep, I know. Let's do this, and I'm just gonna look at that other folder here. Like here. Yeah, there we go. Now we're looking at the right spot. So we had this sim of Flippy. It's just the default, viewport or the configure flip preset. And so I'm going to get rid of these guys because they are not needed for this. That was from some of our other things. And so here we go. We got this, and this should, no, it's not coming in. Why is it not coming in here? Oh, flip points. Yes. let's see what's going on here. I see. Gotta come down here, do this. There we go. That should work. There we go. So now we got Flip. He's animating, right? And so in this case where we want to take some sort of animation like this and turn it into a value clip where we're storing each frame of that information on a separate frame, you can do that with this geometry clip sequence node right here. That's going to, right now what it's doing is kind of looking through all of the frames. And that's because I've changed this drop down here. Before we were doing this with sample current frame. And this is fine, it works. And in this case, it won't really cause any extra data or anything like that to be made. You can see we've got our nice pink value clips here that are showing up. So all of these attributes are coming in as value clips. And so that's doing its thing and working just fine. And in fact, when we go to render this out, or not render it out, but save it to disk using the USD ROP, it's going to go through frame by frame and write these files based on this save clip file path, because we're flattening our clips into USD, each frame into a USD file, and that's works just fine. However, this example over here where we're bringing in BGO files from disk is a little bit of a different scenario. And what I originally had done here was just leave this as is here. So when you uncheck get geometry from second input, you can now load in a path here that'll give us the ability to bring in a BGO sequence. And so this is really interesting, I think, because we're basically bringing BGO files right into Houdini and, basically referencing them right in the USD file. And so we talked about this last time, and that still all works and is fine. However, the reason for doing that a lot of times is one of two things. Either you have a workflow that's already doing using exporting BGO files, and you want to just keep that workflow and not have to convert it to USD files or anything like that, or start building a new part of your pipeline that saves out USD files as opposed to BGO files. So that could be one reason why you'd want to bring BGO files in. Another reason might be that when you're trying to, or another reason why you might want to do a value clip is when you're trying to save these files out, if their individual frame data is too big, it will all tried to get stored in RAM and saved out to disk, and that just doesn't work, right? So that's going to end up, kind of failing, and it's going to overflow your RAM, and it's going to end up crashing your computer or whatever. So that won't work. So the reason to do a value clip a lot of times is because your overall data that you're trying to store in one USD file is too big for the RAM to store it, right? So you're talking about, a lot of times hundreds of gigs in size. And so that's where the value clips come in, and that's why we've improved this process. However, the thing that wasn't abundantly clear to me when I was doing this last time was when you do this in the default setting, you'll see that when you go to save to disk, it's going to run through each of these frames. You might not see it because it's going to happen really quickly. The little dialog might not come up, but in the background there, it just ran through all those files on disk and saved out a USD file for us. And so let's take a look at that real quick here. Where's my folder? There it is. All right, there we go. There we go. Okay, so we get this this value clip sequence here, and there we go. There they all are. And if I change the view to not word wrap, we'll see that we're getting this nice, these files here where we're getting. Geez, that just like jumped super far. Why did it do that? Anyways, we're getting BGO files that we're loading in here, and we're able to see those, right? So that's great. We know that that's working. However, what it did, and it's hard to tell because this isn't a huge file cache, and Epoxia, yeah, LSD is definitely a more interesting name, but what are you gonna do? So anyways, so What you didn't notice when I hit save, or what we sort of didn't really see, was that it actually was running through each of those files again, frame by frame, loading them into memory to check to see if anything's changed, to check to see what's changing, and to make those value clip files, which isn't really what we want it to do, right? We don't need to. We already know that we have things changing, and we really just want to tell it what the sources for those value clips are going to be. So what the way that you want to actually do this is go into this geometry clip sequence and change this up here to sample frame range. And what this is going to do is it's actually going to look at the whole timeline now instead. And it probably won't even look like anything here at all, because I'm basically now going to hit save here, and it should almost instantly save that to disk very, very quickly. And what the difference there is that you couldn't even see the difference really in time. It was slight bit shorter than the other one took. But the difference there was that it didn't load all of that into RAM when it was saving it out, because now it's looking at this whole frame range kind of in its entirety, and it can say, okay, yep, these are the things that are changing. Here's the files that we're making, save it to disk. And so I did some tests with this and was talking to someone on Discord server. I can't remember where this was. I think it, I don't know. I don't really remember exactly where it was, but what ended up happening was that I'm just looking at the image here that I had. So I can probably bring this up here. Let me just do this, and I'll bring this up, and I can kind of show you guys what I was looking at here. So, so without the value clip, this was a fluid simulation here that I was doing. I just brought it in as a geometry sequence. The RAM went up to 86 gigs of RAM, which didn't crash my computer or anything, but that was how much RAM it went up to, and it took a few minutes. And with the value clip, it used a little less RAM, but it still was using a lot. And you can imagine that if this was a large file sequence, you could still run out of RAM. And so in the end, the file was tiny, a few kilobytes, versus this is how big this like ocean simulation thing I was doing. It was a 33 gig file at the end of everything. It took a few minutes. But then this 7 kilobyte file still took a few minutes because it had to load through all of those. It didn't use quite as much RAM, but it still used a lot. And then when I did this time sample value clip, you can see that the RAM basically stayed exactly the same. It took a few seconds. And so like what you just saw there, that time frame was the same time frame it took for this geometry clip sequence with the sampled range here. And so that was kind of the thing that I was missing. And it's something, I guess, is just a good thing to keep in mind, is that when you see these range subframes here, what this is sort of doing is, and if you read this here, it's kind of similar to having a cache node in front of or following this node. And there's some good information in there, and I'm not going to just read that, but it helps with time dependencies. It helps with all of those types of things. So when you see this frame range subframes, just keep that in mind. And I think that in this case, it just was up at the top and just didn't even process for me. And so, so what it's doing is it's looking at the entire sequence as a whole. So it's looking at all of the USD files. And really what we're asking it to do is just load in those files every frame. So what it's doing is it's basically, okay, let's find that list of files. There they are. And then it basically goes, okay, yep, those are our files. Nothing else is really changing. All right, save to disk, we're done. So that's why it goes really quickly. When you do this with the sample frame range set up here, it has to look at each and every frame because you're telling it that each frame exists within its own time slice. USD is really strange in that sense, where a from that standpoint, like, kind of like Alembic, where a static file and an animated file both have the same file path. There's really nothing that tells you that those are animated, except when you open them up and start looking at them, in your project. So there is that that concept, because we're using USD in the background, it kind of flows into this workflow here. And actually, you can have time dependencies in your network without even sometimes seeing them, right? Like this, if we change it to sample current frame, you can see that there is that time dependency right there, right? And so this is a time dependent node, so it has to save it. But what the actual, final result of that is going to be, how that's actually going to impact the scene isn't always really well explained, just because it's not, there's a lot going on underneath. So just keeping that in mind, that you can look at your whole kind of stage as one big kind of time sample. It's kind of like caching out your data frame by frame. And you do have to be careful with that sometimes too, because if you put a cache node down and say cache all frames, well, it's going to cache through the entire scene in a lot of cases. Now, in this case, it's different because we're looking at BGO files from disk. So you kind of have to know when it's appropriate to set those things. And so in my mind, I wasn't really thinking that was something that needed to be done. But it came out when I started playing around with much bigger data sets, and that really highlighted it and was like, oh, okay, I see what's happening here, is that we are actually doing this and changing that. That will affect it and help it to go much faster. But so that's kind of the value clip update that I wanted to show everybody. Hopefully that makes good sense. I think, judging from the comments there, it seems like people are sort of understanding that and it's making sense. There's obviously a lot under the surface happening there, right? There's a lot of things happening, but I think it's an interesting way to kind of look at how USD works. And it's these kind of small changes that you have to make when you're thinking about the processes that are within USD. And the more you do it, the more comfortable it becomes, I think. So the way I discovered this was, I think it was just through testing. I was trying to figure out what was causing the problem, right? So because the whole point of value clips is to not use your RAM. And when I was looking at that chart and seeing that the RAM was going up, I was like, okay, clearly something's wrong here, because this node exists for that not to happen, right? Like, that's the whole point of this workflow. There's literally no other point. Well, not literally, but that's pretty much the only point, is that, like, hey, we've got this really big amount of data and we need to store it effectively. So I knew that something was an issue when I was seeing that. Like, I was literally just watching the RAM usage as I was saving to disk, and you actually just watch it climb and climb and climb and climb, and you're like, okay, yeah, there's definitely something going on here. So it was a few different trial and error type things, but also I asked some of the developers, and we're talking to them as well, and just trying to get some clarity on this, because I wanted to make sure that I was, not putting out information that was totally incorrect, which it wasn't. It was just this one little drop down that kind of makes the issue. And if it's a small file, you're not going to see the difference at all, right? In that case, it doesn't always really make sense to worry about a value clip. It's really better to save it as a file. But if you're in this kind of intermediate file size, it might be better to use a value clip, but you still won't really notice it. It was really the save time that started I was like, why is this taking so long to save? We already are kind of defining what's happening here. So anyways, that's really the main thing there. Hopefully that gives you a bit more understanding. Now, the person I was actually helping on the Discord server and was chatting with was having some other issues beyond that. For me, I was not having any issues, like, after sublayering these files back in and stuff like that. So let's just do that really quick and make sure we're good here. But I think we should be. I named this really stupid. What is this one? That's a horrible name, but there it is. And if we play it back, we're not getting time dependency. Why are we not getting time dependency? Great. Now this isn't working, so I'm confused. Of course. What did I do wrong here? Maybe I'm loading the wrong one. Yep, I'm loading the wrong one. Oh, thank goodness that's the problem. Feel like I'm going crazy here. Okay. Now let's set this back to where it should be. Frame range. Save to disk. That's a great point. All right, let's see here. Now I'm so confused because I definitely did it right a while ago. Let me take a look at this real quick, make sure I'm looking at the right thing here. All right. I am not sure what's going on there, but we're going to move on because now I'm going to have to do another update of this because I have no idea what's happening here. Let me do this. Let me actually do one more thing. Sorry. I'm going to open this, open a new version up, and take a look at that project that I just had. Give me a second. The fun of doing stuff live. All right, let Houdini boot up here, and then we'll keep going. Thanks. Thanks, Epoxia. All right, let me open that project file. All right. Okay, so this was the scene that I was talking about here. got a big ocean simulation and a thing comes up out of it, blah, blah, blah. Very exciting. Let's sublayer that in. Where did I save this to? USD. Sample range. Okay. Well, that's working just fine. So I'm not sure what the difference is there. Let me take a look here. Clips of matching scene graph structure. Flip sim. Oh, I wonder. Okay. The one thing that you have to have is this USD configure in between running with the sample frame and import path prefix. I wonder if I didn't save that out on the other one. That could very well be it, and that was why it wasn't updating properly, like time-wise, because this one's in the same setup. Let me just double check here. That's the next one we're going to look at. So, I mean, I could just check that on. That was fine. We weren't flattening. That's good. App.os. Yep, let me just save it one more time. Just make sure I'm not losing my mind. And yeah, it's got to be what it is that the time wasn't saved on there, so it wasn't getting that. That's 100% has to be what it was, because this is a much larger simulation, and you can see here that it's playing back just fine. We're loading in the file that came from this sampled value clip here, and if we yeah, value clips are really cool when I'm not doing something dumb and making them not work, but they do work. So anyways, please trust me that's that's the thing. Yeah, here we're saving that out, and we're going to this USD file right here, and just to show you what that file looks like, I will go to that as well. Side effects. Well, you shouldn't 100% trust me, but I'm pretty sure that this should work now. But anyways, when we look at these here, you can see that this sampled range value clip is a 7 kilobyte file. There's this gigantic single file USD. So anyways, those are all doing their thing. It's working in this case. I think it was because I didn't save that cache out properly. My mistake. But anyways, there it is. There's the workflow that you want to do. And hopefully that makes sense. So we'll move along from that and let Houdini stop hopefully making a complete fool of me. So let's get over to this scene here and talk a little bit about what we were doing before on Monday, actually. And while everything worked great, we did some fun little stuff. We did a little like a little simulation here with these candies falling into the bowl, and did some mops related things with it, doing some, like mixing effects and things like that. And so we were talking about this, and then we were like, okay, how would we bring this back into USD? And because we started with USD, right? And we wanted to bring it back. Well, there was a couple of things that I wasn't thinking about really well. And the reason that I was, first of all, I was just kind of was thinking more about the mop stuff and not about the actual USD side of things. And so one thing to keep in mind here is that while we have, so let's just look at the Solaris side of things here. We had these candy hearts that we brought in. We did all of our heart variations. And then I just applied a little override to hide the original candy hearts right here. Basically what that does is just turns this off. And now the only thing we have in here is our effects with our heart variants and the candy hearts below it. There they all are. And I think there's 18 different ones. And so that was all working just fine. However, I was thinking like, I need to keep all of this USD data as we go through them and make sure that we have all these specific hearts that we're going to be using. However, we don't need to do that. That was a really silly thing for me to do, because what we actually need to do is we need to use these as the sources for our instancing, right? And not worry too much about that. So there's kind of two different concepts here that could be done. You could have something that you're laying out in USD, right? So let's say we were doing these hearts and we were laying them out here, and we had some sort of setup that we wanted to do where we move these hearts around in all these different ways. That's something that we could obviously do and set up a scene that way. But what we wanted to do more specifically was bring these over into SOPs, do a little simulation. So we kind of brought them in as these hearts. We unpacked them. I did a little poly reduce on them. In fact, probably what I should have done to make this even more efficient would be to like do a remesh on them or something and get even less polys on it, because we don't need to bring this geometry back in. That was the mistake that I was missing in my mind. We don't need to bring all of this geometry back in. Now, this step here where we're getting the attribute from pieces, we have a grid here, and we're getting these points from this volume here, and then just doing some transferring randomly those attributes there onto it. So we've got these different, we're basically randomly selecting one of these hearts. And then down here, what I could actually do is show the name attribute here, I think. Oh, no, that's not going to show up because it's pack geometry, right? I think that's the problem here. Let me just... Yeah, that's the deal. But if we were to, let's see, how could we do this? Actually, I'll unpack and instance this, and we can do this. Oh, maybe it would have showed up. It just wasn't in color mode. Color, random from attribute. Okay, cool. So that should show the different ones. And then if we pack an instance, will we still see that? No. Okay. Well, anyways, so what I was doing here was basically, what you can see is the different, there's like there's 18 different colors in here. So these are all different, or not colors, but different, variants, right? Because we had 3 geometry and 6, rough, 6 color variations. So 3 roughness and like geometry variations, 6 color. So that's kind of the entire thing that we brought in here. And that's fine. You could do this, but you also don't even have to worry about that, right? These are all so close in shape that you could literally just use one and randomly assign the pieces based on that. So like it doesn't have to be that way, right here, while this has all the pieces in it, right? This has all of the different options. You could probably just pull this in over to here, I think, and we'd still be fine. Yep, that's still going to add in our variance, right? But at this point here, at this poly reduce, what we could do is just select one of them, right? So we could just do something like a blast here. And so now we should have geometry at this point. And let's just say we're just going to take one of these hearts, right? So we have one of the hearts. And that's fine. We don't need to, we'll just delete non-selected. So this is just one of them. I'm going to hide the ghosting here. So here's our one heart, right? Now this is just the rough geometry. All the other ones are all very similar to it. So really it's just this general shape that we want to grab. And we could do a remesh here, right? And we could just kind of tweak this until we get a rough shape that's close. Yeah, I think like 0.05 might work. That looks pretty good. I mean, we're just looking for some sort of a really rough shape to bring in that can be used by our rigid body solver, right? So now if we copy this to points, we're going to be pulling all of those elements there. And what we could do, we could now just say, don't use this piece attribute, right? And instead, it's just going to copy that attribute on there, right? And so that geometry doesn't really matter. So what we're doing here, so let's pack and instance this, and we should see, yep, we still have all of our variants and all this stuff kind of randomly assigned, but now we just have the same geometry representing all of these. And really that's going to be a much smaller bit of geometry to deal with, and that's fine. We don't really have to worry about this name attribute here. We could, if we want to, whatever. It's totally up to us. Now, in this case, this name is going to be our variant. So what we could do is we could just, instead of deleting it, we could do an attribute rename and just go from like something like, let's see, from name to variant, something like that. And now this will come through here. We'll do all of our variation, all that stuff. We're going to come to our RBD configure. And at this point, we now have our pieces and all of that stuff should be existing there. And we have our variant still down here. So we know what variant we're dealing with, and we know kind of what the geometry is. Those have individual names on them, which is really important for the RBD side of things, right? Each piece needs to have its own variant and weighting and stuff like that. So now what we should be able to do here is, let's see here, if we hit play, this should run a bajillion times faster. You can see how quickly it kind of booted up and started going. This should work way faster, basically, because we're dealing with a lot less geometry. We could have probably gone through and made proxy geometry that matched up and all that kind of stuff, but in my mind, that just wasn't really worth it for what we were doing here. Just reducing the size of this original geometry is fine. And what I'm actually going to do here, I'm going to go inside and just, I think it was, oh, interesting. Cool. Apparently didn't like something I did there. Don't go inside. We will reopen that real quick. Sorry about that, folks. So La Pampadura, you're asking, it'll just move the high poly along the RBD low poly. Sort of. Bye, Tom. Have a great evening. Enjoy using Linux at home. All right, let me just open up my directory here and just get the last modified. There we go. Accept. And I'm going to save this as stream project files. Candy hearts. There we go. Overwrite. Perfect. So yeah, what you were thinking about is the proxy workflow. We're not even really dealing with that because the proxies and the actual objects all need to be named the same, and you need to do a whole bunch of different stuff with that. So to take the trickiness out of that, of dealing with all that stuff, we're just having the one geometry be the low poly version, basically. And you'll see in a second that we're not going to do this down here anymore. But what I was going to do is come in here and look at this, and I'm going to turn off snap by distance. I don't want it to snap back into place. I actually kind of like the floatiness of it. So let's see this again here. You can see how much more quickly it kind of starts up. If you were watching on Monday, it kind of like sat for a second and like tried to figure out everything because it was like, wait, this is a lot of geometry. Now it's a little happier. Anyways, we'll let this kind of run through, get the solve done. And then it kind of will shoot back into its final stage there. Cool. Anyways, it could be better, but we were sort of playing around with the idea of yes, and Keith is exactly right. And that was what Henry Toadstorm mentioned to me last time, and I was like, yeah, I'm so stupid. Why did I do that? So anyways, so this is now our simulation. We've got this all working. We also should have our variants here still. Yep. Good. Which will be important. That'll be helpful to us. And we'll see why that'll be helpful in a little bit. So let's now take a look at this. So here, what I was thinking was like, oh, we'll unpack it and it'll have like some of this original USD stuff on it, but now it doesn't. So like, that's not really working. So, okay, let's get rid of that. So what we can do instead is we can take out the simulation points here. And so let's just put a null down first and take a look at what we've got coming out here. And I have my my little axes turned on so we can see those. And so what we should have here are our attributes coming out. And I am going to make sure, I think what I need to do is transfer the variant over. Let me see if that did it. Yeah, there we go. Perfect. So this is basically the kind of the point-based version of this, like any of these other things. It's basically just turning it into points for us, more or less. So it's kind of taking all the geometry and just giving us these sourced points. We have the colors and all these different things here, but I'm just going to say out sim points here. And so this is going to be what we're going to use to get our our geometry sourced onto it. So here I'm just going to hit green like that. Great. Okay. So now we can see we've got some points here that kind of fall down, do their thing, blah, blah, blah. And then, they'll go back to where they were in the beginning, and great. All done. Oh, interesting. It's not bringing the orientation back to the right spot. That's interesting. Why is it doing that? I wonder if I changed this, if that would work. This is actually time sampled, so I wonder if that was part of it. Oh, no, apparently not. Oh, I know why, because it's not activating them. I'm just going to add another null in here. Just curious if that's going to help me. The activation. Color these yellow as I like to. Sorry, I'm just going through and just making a quick adjustment here. I think this will, because I just need to make sure these activate. That was what this one was doing. So let's see here. I'm curious if that will bring us back to where we were before. It might have just been me setting a setting wrong in there. That's why it's kind of going back to that random orientation, but whatever. It's not really the end of the world. I could maybe take a look at why it's doing that. I wasn't really noticing that. I was doing that. Okay, that looks like that's maybe more correct. Let's just double check here. Oh, that's weird. It's definitely keeping their orientation different. It might be something here that it's actually calculating an orientation for these. Maybe if I turned that off, maybe that would do. Yeah, they shifted. I agree. Yep. I saw that. Let's see. Did that fix it? No, that doesn't fix it. Yeah, they do shift there. I'm just noticing that. So what I think this might be is there was a similar thing that was happening with emitting vellum shape match stuff that I was playing around with, and kind of wonder if that was the issue, if this is the same thing where there's like a different calculation for the orientation that's going on inside of the solver, and this might help it where we're solving it on the creation frame. Maybe not. I don't know. No, it is still moving. That is really strange. I'd have to look at that, see exactly what's going on there. Anyways, that's not why we're here to figure that one little thing out, but anyways. Yeah, very odd. Anyways, these are working, so we're gonna come back over to Solaris and work with those. So we have these. Let me make this a little bigger here. So we have all these hearts in here, right? And we had this 2 effects, right? So now what we could do is we could do a instancer. And with our instancer, we need to give it our prototypes, right? Now we don't have a stage at all, so that's fine. But we need to get stuff into it, right? So what we could do is we could do an internal SOP, we could do an external SOP. Now I'm going to do it as the internal SOP. I think that'll be the easiest to do, so we can make maybe some modifications in here. So I'm just going to do an object merge just to bring that data in. And let's grab the out sim points here. Great. So there's those. And what I'm going to do is I am going to... Oh, I'm not getting the variance. Well, that's okay. I can change this. I don't know why it's not giving us those. Why it's not giving those anymore. Let me just double check here. Maybe it was this that was helping us with that. Let me just double check. Yeah, it's not actually coming out. That's okay. We'll just take this and we'll just do an add node, or we'll do the extract, extract all points, and that we can just get points from as well. So that's fine. This will work just fine as well. This is the same basic information. And so that should work. We'll bring that over here into Solaris. Great. You can see things are already starting to happen. We need to tweak some stuff here, but that's okay. All right, so we've got our points here. So what we need to do, let's say get sim points. And so what we need to do is we need to change the name attribute here, right? Because now these names are the names of the pieces that came in, and we actually want to give it the names of these variants. So let's just it could be because of the centroid. That's a good point. I have a feeling it was more to do with something about the way the orientation was calculated. That would be my guess, but I'm not 100% sure. I have a feeling it's something with the orient attribute that's something got goofed up there somewhere. So there's I didn't even make this geometry, so there could be attributes here that are messing with it. I don't know. So there's some stuff I'd have to look into there, but it's not worth it to try to figure that one little thing out. We can just pretend that initial orientation was exactly how we wanted it to be set up. Can I do an attribute swap? Is that? I think that'll work. Oh, yeah. I could have used. Could I have used extract centroid? I might have been able to. However, the reason I did the one I did was because what is this? Are these packed? Yeah, these are packed geos. So just extracting the point gives you the pivot anyways. So I think if you were extracting the centroid, you would do that from unpacked geometry. I'm thinking, right? I think that's like if I did extract centroid here, I think that would give us the centroid of that geometry, right? So that would be different than its, whatever its pivot point or whatnot, right? So this is the centroid of this mesh here. But what I was doing, so this is saying center of mass. You could do bounding box center, convex hull center, all that kind of stuff. So, so I knew we already had the these are packed geometry, so they already exist as just points. So that's why I'm extracting all points from it, as opposed to trying to extract the centroids, because we already kind of have. No, I don't think it would. No, I don't think it would. It wouldn't copy the rotation around as far as I know. I've never tried that, because usually if you're doing something like this, no, I don't think it would. Let's see, extract centroid. What does that do again? I mean, you could transfer the attribute, I guess, right? Like if you had an orientation or something like that. Like if we, let's see, if we unpacked this, right? If we unpacked this, transferred the name and orient over, and then extracted the centroid from it based on name. Hello. Interesting. Okay. is that not? Oh, I see. It's on the primitive one. So I'd need to do this and then attribute. Like, why is that not running over it? Let's just see. Let's give it a shot, right? Why not? Not attribute transfer, attribute promote. Sorry. Attribute promote. We'll take name from point, go to primitive. There we go. And then if we transfer the attribute, let's see, I think we also need to do orient as well. There we go. I mean, yeah, technically it's working. It's just really slow. I guess you could do that. It's just way easier to do this because you can play it back in like real time, basically, right? Oh, actually, that was simulating. I didn't realize that wasn't cached. Let's see. How fast is this? Yeah, it's a big hit in performance. I mean, it's not terrible, but it's not great. So anyways, you could do it. It's just, we already have the centroids and all the attributes that we need. So good enough there. Actually, you know what I'm going to do? I'm going to do an RBDIO here just to get this saved to disk so I don't have to keep worrying about that. I'm just going to do geometry. It doesn't really matter. We'll just save that to disk and background. Let it do its thing. That way I don't have to keep resimulating this when things goof up. What is it doing? Okay, it's working. I was like, is this not working? It's like, what is happening? Okay, anyways, that should connect there. We've got centroids out. Great. Yep, looking good. Okay, so that's all working. I'm going to let that run for a second. I'm actually going to take a quick break, grab a drink, and I'll be back in a second. I just want to give myself a little break here, and we'll be back in a short bit. So, yeah, give me a second, and we'll be right back. See you in a minute, guys. All right, everybody. Thanks for hanging in there for a second. Just got myself some water. And the simulation is almost done. Got a few frames left. So we'll do that. I see that's what was erroring out on me there. All right. So we've got our points now. Everything's looking pretty good. And we're back. Hopefully all my audio's good here. Hey, Drew. Welcome. I think we're good. Just about. There we go. Last few frames. Great. All right. So we've got our simulation points out. All good. Let's hop over to Solaris again. And yeah, you can see we're really crawling here, but that's okay because we got too much geometry. So, hey, alrighty, let's take a look here. So now we should have our variant here. So let's wire this in, and let's say source is going to be variant, destination is going to be name. Yep, perfect. Let's just set this to copy. What does move do actually? What does that do? Oh, see, it's funny. I've done this before, and I think I didn't realize that there was an attribute swap node. I don't know how I missed that, but it's really nice because you can just move one thing to the other. So that's really great. Anyways, so that should give us our name attributes that will match up to these, to the variants that we've kind of looked at in this scene. So now we've got our simulation. We've got our named attributes here. In fact, we could probably just do an attribute delete here. And yeah, exactly. Tom, you're exactly right. Andrew waited for you to leave, or for him to leave, and you to join, for him to leave, whatever. My brain's not working right. But yes, you guys missed each other. Tom. All right, so let's take a look at this here. I'm just going to keep only the ones I want. So I'm going to say delete non-selected and just keep name, variant, orientation. Oops. Is there a V here as well? Are we getting velocity? Yeah, let's get velocity and W in here as well. We'll just do velocity. We don't need W. There goes Drew. He's out. He sees that Tom is in the chat and he doesn't even want to be in the chat. He left. I don't know. Are you still in Toronto? Drew? I don't know. I don't know where you are, but maybe he left Toronto just because Tom was coming. All right, let's see here. So we got the swap. Everything's looking good there. We've got our name, which is now related to the variant. We kind of stored that while we were doing our simulation. Now we're moving it back over just to kind of see here. You can see variant and name. We're moving that over here and getting rid of variant. We don't need that. So all good. So now the last little bit of this is kind of knowing what we can do with these target points, prototypes, all this kind of stuff. So the other thing we need to do is, I think, p-scale as well. There we go. One last bit. And I'm just going to say output. I'm going to give an output in here so we don't accidentally move a display flag around or anything. So you're back in LA because, man, you had to go across the whole continent just to make sure you didn't run into anybody. Yep. Makes sense. All right. So we've got the orientation. We've got the scale. All that stuff's looking good. Cool. All right. So now the thing to keep in mind here is that we have our prototype primitives that are looking at this second input, but sometimes you might need to be more specific with that, right? So what we could do here is we could bring candy hearts over and then just add a /* to the end of it. And that should, no, sorry. Is it double star? Okay. Interesting. Yeah, no problem, man. Well, thanks for joining us for a bit. Let's see here. Let's undo that. Okay. That's weird. I don't know. I think what it's saying is that because these heart variants are within this reference, they've been referenced up here. I was having a hard time pulling those out. So what we can do here is we can take the name attribute. Nope, that's the same thing. Let's see here. All right, so let's undo that. Let's not create references. Okay, so this should be what we want. Star. Now it's not finding the prototype primitives. That's interesting. Let's turn this off and just say random again. Oh. Oh, I see. I just grabbed the wrong thing here. Throw this over here. There we go. Nice. Nice, Drew. All right, I'm just looking to see why this is. What's going on here? Because this was fine a second ago. So what do we do that's the problem here? Got the points. That's all going fine. All right, let me just do one thing here. What is it doing? Okay, it must be this thing that's freaking it out. Just gonna throw something in here, make sure we're not. This was supposed to be the easy part. All right. Let me just see if this will do it. Oh no, sorry. Layer. There we go. It's interesting. I'm not sure what's going on there. Oh, cool. That's great. Razvan, I think that might be how you say your name. No, don't worry. No worry about interrupting. That's great. So I think, let's see, does that work? No. Interesting. Well, for some reason, I'm not thinking of what the exact reasoning is here. Let's see here. So if we flatten the input stage here, we've got those. Oh. There's the problem. One checkbox. What a dummy. Okay. Sorry about that, folks. Yeah, Matistel is awesome. Very good. Very good guy. And a lot of fun to just chat with and stuff like that. So, all right. Let's just try one more thing here. So, let's do this. And let me just do this again. Okay, let me do this and then create that. There we go. Okay, so let me explain what I think was happening here. I was just missing one dumb little thing, and it was this checkbox. So with this checkbox on, this is basically saying, should we copy the prototype primitives or not? And so when we have this off, what it's going to do is allow you to have these other references and things like that living in these prototypes. Because if we were trying to copy them over, I think it isn't able to do that when you're doing references like this. You can see those are happening here because of the green and yellow and stuff like that. So the yellow are payloaded. Those are the actual assets that we're bringing in. This composition arc here, this is a reference that was made at this point here. If I turn off create references, that will not exist there. And actually it breaks it as well. So that's part of, so it's like, there's a lot of little things that if you do it just the wrong way, it's not going to want to do it. So in this case, we're good because we're referencing things here. So that's great. And that's by default on. So that's good. We applied that override. That was just hiding this the original candy hearts, because here you can see that this candy hearts was the original piece. And then we set this duplicate and then that comes in here. So that's all looking good. I think we're fine now. And so really that's the main thing, is to turn off this only copy specified prototype primitives. If we were creating this all on the stage here and all doing this in kind of in the RAM, kind of in scene here, it would be fine to have that only copy specified prototype primitives on. But because we're actually referencing from disk and there's all these things kind of embedded into the workflow that we're doing, that's what we're running into, and that's the problem we were hitting there. So anyways, I'm gonna get rid of this grid because we don't need it. I just was looking to see if that would make it a little happier. Let's hit play here, see if this should work. Yep, there we go. We've got referenced geometry here. Yeah, so I think if we were doing something here like, let me think, how could I recreate that quickly? Yeah, probably if you're doing something like a SOP create or something that was all existing here in kind of, I guess the best way to think of this is that this is a file on disk, right? So it has certain things baked into it, right? So this payload is a type of reference that's baked into it, right? So we can't get rid of that payload. And when we're referencing it here, then this is allowing us to reference all these payloaded variants here. So this is, again, just more of that. It's basically, these are instances more or less of this original here. So then we just hide that original. And now we have these things that are all kind of embedded inside of each other. And so because of that, that makes it where we can have some issues if we're trying to just copy those just straight up, into a different part of the scene. So because of that, we turn off this only copy specified prototype primitives. It kind of brings the whole stage in there. You can see the candy hearts is still in here in the prototypes, but we don't need that. And we have all of our effects and all this stuff in here, but those are just the prototypes right under this instancer. So we could say here, these are going to be our candy hearts instances, something like that. Right. And so now we're kind of doing something that's making more sense here. We have our prototypes, which are in there. And this is a point instancer, I should make the note of. We could also do this as an instanceable reference. You can see here now we have all of these instances that are being built here. However, as you could see from the viewport, it just took quite a bit of time to do that. The reason for that is now each of these kind of exists as their own instance in the scene, which it can be fine. It can be good for certain things. But in our case, that's not really going to be what we want to do because it's going to take, really when you have instanceable references, that means that you could do, it kind of gives you a little more flexibility to change things. You could if this was all the same original candy heart, you could actually randomize the variant on them if they're instanceable references. So there's a bit more flexibility there. But you get a performance hit. So something to keep in mind when we have these point instances, it's really fast because we're basically just selecting which instance we're bringing in and copying to which specific, frame or to which specific point. So there that is. Let's also bring in the bowl, right? We made this little bowl. Why not bring that in? So I'm just going to hit a null here. Oh, actually the bowl is up here, right? There's our bowl. So we'll come up here. We'll do a SOP create here. So this is going to be bowl. Oh no, not SOP create. Sorry, SOP import. So there's that. Let's get that reference here, bowl. So now there's our bowl coming into the scene. Cool. There's our SOP create. Looking good. This is just going to be we'll call this candy bowl. And there's our candy hearts instances. Looking good there. And what I would say that we probably would want to do, let's see, I'll add a grid as well. That just will be a nice little ground plane kind of thing here. We'll just say, I don't know, we'll just call it a table. It's not a table, but it'll fill the need. And then we can add a couple other things in here if we wanted to. Maybe we can do a physical sky. Really like this Karma physical sky. It looks really nice, I think. So we'll do that. And, we could clean this up a little bit too. So we could put these into like scene geo like this, add this table. We can do the same thing for the candy bowl. We'll just copy this right over. It's always nice to kind of make things organized, right? So we have our scene geo, we have our lights that are going to go in here. This could also go into scene geo, so we could just copy and paste that there. So now we have our lights, our scene geo there. All right, that's all doing its thing. Let's see here. What else? What else? And then I guess we could actually, might make more sense. Let's just cut that. Might make more sense to actually wear these in like this. The only thing to keep in mind here is that this is going to be now have a time dependency, which is fine. I mean, I guess. Yeah, it's just something to think about. Oh, you know what? Here too, we're doing these random. Let's do the name attribute. That now is working. So now the name attribute is effectively picking which instance it's going off of from the prototype. So that's good. If we go back here, we can see that that is now working. So great. So we could do random and it would just randomly select them and we could have an index here, or we could use the name attribute to make sure that that is done properly. Let's do a material linker. And what I'm going to do is I'm going to hide this material list on the left here. I'm going to go to the catalog, make this maybe a little bigger, and let's just grab some elements that we can do. So let's do a ceramic bowl. So we'll drag that over. And now we're making some materials here. And for the table, we'll just do something simple like a wood table, something like that. Let's add a camera in here. So let's just kind of do this. We'll do camera, drop that down. Cool. And then let's do a karma node just to get our final thing going here. And yes, you can. It is really neat. So what you can do here is if you do open AMD Material X library, we can set up where we want this to live. And so here, Houdini Hangout, stream project files, and we could just say AMD Mat X, something like that. Hit accept. And now it's going to bring all of those from disk here. So if we wanted to do something, these are some really cool materials as well. So maybe we could grab one of these and use one. Let's see here. I don't know. Is there like a... Here, I'm just going to make this a little bigger so we can read it. Is there like a wood? Yeah, there's some wood ones here. Cool. Let's do that. We'll grab that, throw that on there. Oh, actually, you know what? That's right. You want to be on this actual material linker when you do that. Otherwise, it tries to make the references later down the chain, and that just gets a little funky. So that should work. In fact, I think you might see it in the viewport. Maybe. I guess not. Some of them I feel like you see in the viewport, but it doesn't look like that one is seen in the viewport. So that's interesting. Anyways, all right, so let's look through our camera again here, and I'm just gonna hide this, and let's grab, oh, you know why it probably wasn't showing up was because this doesn't even have like UVs or anything. Let's see, UV project. Sure. There we go. That looks a little nicer. We've got a ceramic bowl of some kind there. Just kind of move this around here. See what we got. But yeah, now we've got all of our different geometry that's instanced there. And we've got our, geometry from the bowl and all that kind of stuff, the table. And yeah, so we've got a nice instanced scene here with our geometry and everything looking pretty nice. So hopefully that gives everybody a little bit more of an actual idea of how you would bring this over. And the nice thing is here, we're just using this same stream basically that we sent over to kind of reference in SOPs. And since we had, since we were able to do that and bring them all over and kind of have a catalog, kind of a library of these different variants that we're going to be using, then we can effectively kind of source those back on using the attributes, the name attribute that we brought back over. So kind of a fun little thing to do there. And yeah, looks like we got a nice little bowl of candy hearts here. Yeah, something. Let's see here. Could maybe make it a little more like a little more sunset-y. Something like that. Yeah, I mean, so really it's about knowing your kind of your course of action, like what your process is going to be, and knowing what the best kind of way to go about doing that is, right? Like um there's certainly a bunch of different things that you can do, right? Like you could set your scene up in Solaris, do something with it in SOPs then, and then bring it back in. Yeah, destruction is a little trickier because if you're, depending on how you're fracturing it and stuff like that, that would be, that could be tricky. There is actually the RBD destruction lop. This actually has like an RBD destruction workflow inside of it. So there's SOPs inside of it that are doing the fracture and all this kind of stuff. So if you do all of your destruction simulation in here and cache it out and all that kind of stuff, like it can just live in line. Basically, you can do all your fracture, all that stuff right here. And so, that can be a really cool way of doing it too. So you just kind of set your primitives, your collision primitives, and this actually has a render time procedural that will transform the points. I think I talked about this a little bit in the procedural, the Solaris procedurals when we went through those. I talked about it a little bit there. So that might be something to go back and take a look at for that conversation. But yeah, so that's kind of a fun. Yeah, okay, cool. I did. Yes, I thought you were there for that. So I thought, yeah. Anyways, kind of a fun little example of how you could do that stuff. So there we go. We've got our instanced hearts back in here with some shading and all that kind of stuff. And we've got all of our animation and all those things going on. And Keith, I think that's a great question. I think it could be, it could become a bit more normal in the future to do things like that. I think it's a good way of kind of imagining the stage context in some ways. There's a lot more strict rules. That's the problem that a lot of people run into. And in fact, I ran into here where I wasn't thinking about how I was doing things. And then one little checkbox was like, oh, I need to check that, and everything was fixed. So there certainly is a lot less flexibility on the stage using Solaris than there is in object context. But when it comes to production workflows, I think it will be able to kind of be a bit more seamless because this is all USD, right? So this could come from anywhere, right? It doesn't have to all be, it doesn't all have to be Houdini stuff that you're doing. So yes, I think it could be possible. I think people get into some issues when they're like, oh, I want to do this simulation. Why don't I just do it as do it all in like a SOP modify? But this has its own tricky issues with it too, because in here, it has to, the kind of incoming and outgoing data has to be sort of the same. So it's tough to you have to make sure that your data stays really consistent through it. And that was what I was thinking I was going to need to do, going over to, bringing all the geometry over and all that stuff. So I was just, not thinking of it kind of correctly there. But I think it could replace it at some point maybe, but I really don't see the object level going away. I think its use could become less thought of as a place to set up your scene maybe, but it's not going to go away. I mean, it still is how you organize objects within Houdini, right? It makes sense to do that, but yeah, I think for the final workflow stuff, that's interesting. That's an interesting take on it, Carlos. Yeah, I think you have to really start to look at things quite a bit differently when you're working with Solaris because it is USD. It doesn't give you the same, like Houdini in the object level is made to be really, really flexible, right? And you can do a lot of stuff and it sort of just gives you the grace to do that. Whereas in Solaris, there are a lot more limitations as far as what you can and can't do that will work. So if you do something the wrong way, it probably just won't work. It's not just it's kind of like digital signals. Like it doesn't just get fuzzy and get worse and worse and worse. It just kind of works or doesn't, you know what I mean? So, it's a very different way of having, you don't have quite the same flexibility as far as, I'm just going to do this, this, and this, and yeah, it'll probably work. It'll be fine. You kind of have to know where you're headed from the beginning and plan quite a bit, which is why it's really great for movies, because that's what you're doing. You're getting things, ready from the start, and, you kind of know where you're heading with it. That being said, I do feel like it handles instancing and huge scenes really, really well. And those are things that are really, I think, exciting. But it definitely takes time. So it's not just like a instantaneous, oh, I know how to do this and it's all good. I mean, I've been messing around in Solaris and doing training on it and all that stuff for a year and a half now. And, I still make goofy mistakes like this that are sort of tricky to know if you've done right or not. But yeah, so I think it's tricky. When geometry has to be changed in a fast workflow. Yeah, I think it really depends on what you're doing. I think that's the thing, is you have to know what its strengths and weaknesses are and when those things happen. Like you can't just only work in Solaris and think that that's how it's going to be. Like it's really more of the end of the chain than something to do kind of in the middle. It's kind of the end of it, right? Like we did all of our stuff in SOPs and then came over here and did this. We set up some stuff with these candy hearts and stuff up here. But really that was just to prepare it to come to effects, right? Like that was really all we were doing. So yeah, it really needs to be the end of your chain in some ways. It's not always best in the middle, if that makes sense. Unless you're really able to control the incoming and outgoing data. But yeah, and Karma is relatively new, honestly. It's only been out for a few versions, and Karma XPU is really new as well. Karma CPU has a lot more flexibility than Karma XPU does, and always really will. I mean, it's a different render engine. It's running the same thing with Arnold and all that kind of stuff. Redshift's a little different in some ways because it's only a GPU render, so you really have no other option. You just have to there's only one way of doing it. But anyways, yeah, I think it's really, it'll click at some point. That's the thing, is that there'll be a moment where you'll go, oh, okay, I think I finally got this. And it takes a little bit, but you'll get there for sure. And like a ton of the industry is using it. Yeah, it might not ever be the best way to do a quick abstract thing in motion graphics world. But really what you don't want to be doing with it is going in and out of it like constantly from Solaris to SOPs to Solaris to SOPs, like as you go down your chain. Like you really want your SOP stuff to kind of all flow in. And then as you make changes and adjustments to those SOP geometries up at the top, it'll just flow through your network and you'll get your shaders applied and all that kind of stuff. So that's really, I think, the way to think of it more than trying to like make modifications to geometry midway through. Anyways, I could probably just sit here and talk about nothing for a while, but anyways, that's that. Yeah, so I think that's kind of the end of what oh, hey Jeff. Exactly. Sops for sops work. I'm shocked you're here, Jeff. Nice to have you. um anyways, um yeah, what was I saying? Anyways, so if anybody has any other questions or anything like that, happy to kind of uh talk about other stuff if you have questions or thoughts or anything like that. Um if not, that's great. We can kind of we'll wrap up not early. I mean, it's been an hour 45, but um yeah. So if anybody has any other thoughts or questions or anything that they've been kind of curious about and want to just ask a question maybe that we can do here a little bit at the end, happy to take them, but I'll give everybody a little bit of time to kind of gather up some questions if they have them. Oh, thanks, Ankit. I appreciate that. Yeah, they're very different. They were originally made. Those videos were originally made for like professors and instructors and things like that. Um, so the legend. um, so those USD videos were made for professors and made for teaching, really, a little bit more so. And so they were not really made in any type of like project based kind of pretty type stuff. It's a little bit more in the weeds of learning why things do what they do. And so it's a little bit different than a lot of the stuff that, Side Effects will put out in that case. So it's just, yeah, it was a little bit of a different aim, and the marketing team asked us, hey, would it be okay if we put this on the website? And I said, sure, yeah, of course. Not really that. I mean, it's very technical and very kind of concept oriented, a lot of programmer art, but yeah, I think people have really gotten stuff out of it, so I appreciate that. Thank you for the comment. That's very nice. Epoxy, any PDG episode? That's a good question. Is there some, if there's something you'd like, if there's some kind of idea that you'd like to see with PDG, I'd love for you to put a suggestion on the Discord. Happy to look at that. If there's so many different things you could do with PDG. There's also a really great like intro to PDG that our education team intern Daniel did. That was really awesome. Really nice kind of introductory. If you're not familiar with it, he kind of goes through like a little city generator. And I think actually, now that I'm thinking of it, I feel like Rob McGee might have used that and kind of integrated that into the Houdini Foundation's material as well. So that, that might be a place to look for that as well. But I don't have anything planned, but like I said, I'm always open to suggestions. So yeah, if you, I see. Made a nice cloud today. Just wanted to export. Yeah. Yeah, maybe just doing some simple geometry manipulation would be a cool thing. I mean, certainly if people are interested in PDG and learning more about that, I'd be happy to talk about that. Obviously, I'm not. If you want, Tom Waffle Boy Tom, he's quite the tops guy. He loves playing around in there. So he would. I would be nervous to have him watching over my shoulder because he'd be like, "Oh, Pete, you could do this better." But no, I'm just kidding. But yeah, no, like definitely some geometry manipulation could be really cool. That's a neat idea. Like to have something with with like variations and stuff. Drew, you asked a little earlier, is USD instancing new in Solaris? No, instancing really has been there. It's part of USD and has been kind of since the beginning. I think the workflows have become maybe a little bit easier to work with, but I think the instancer was there from the start. I can't say that for sure because I haven't been using Solaris really heavily I haven't been using it since the very beginning, so I don't know. But no, the instancing has been around for a little bit. I'm guessing probably from the beginning. And it really works very similar to the copy to points. That's the best way to kind of think of it, is you're kind of copying the points. It works like the workflow is a little different, but in the end you put points inside and it copies to them. Oh, that's really cool, Chris. Yeah, Fraser is awesome. I've ran into Fraser a couple different times. I think at SIGGRAPH and at a couple other events or something like that. He's a really great. He just seems like a really good teacher, and that's really cool to hear. I'll have to keep that one in mind. One-stop shop for the generalist. That's cool. Yeah, that might be something to check out. Carlos, I know you were mentioning that before. Just about kind of running into that. And yeah, I use PDG in a lot of different things. A lot of times I'll make a setup, like a scene or something like that for a training. And if you need to run some simulations as like source material, I'll just set those all up to run through PDG. And so that way it goes through and fires those all off and cooks them all, while the person, when they load the scene up, they can just hit one thing and just have it render everything out or cache out everything that they need. And that way they're in a good shape. So it really isn't too bad. I think the tricky thing about trying to talk too much about PDG is that usually the processes that you're automating are long, right? And so when you're automating big processes, it can be hard to show that in a way like non-real time, like in a real-time environment like this, where you're kind of dealing with a live environment. You don't want to have everybody sitting there for 20 minutes while things cache to disk. So that'll be a tricky thing to do, and I probably will have to think about that. But wedging, like the concept of wedging variations and things like that, you wake up the next day to 12 versions that look exactly the same. Exactly. Yes. I'm sure plenty of people have their horror stories of that. And back in the day, there was the wedging workflows in ROPS too. On the topic of future streams, will there be any that can go over transforms inside solvers? That's interesting. I'm not sure exactly what that means, but like rotate a point around a position. Oh, I see what you're saying. Like around a moving position or something like that. Like, yeah, that would be like matrix stuff. If you were like going around all like positions and using rotations and things like that. I think that's what that would be. Yeah, I'm always up for making suggestions and things like that. I'm not always like, usually it's like I'll see something and be like, oh, I got a great idea for that, and then go into it. So I don't always just like, oh, this is the next one up on the list, I'm going to do this one. But sometimes it takes like me looking at it a few times and thinking about it. Yeah, that maybe could be one for a Mops Monday. Yeah, if you guys have suggestions, throw them in the Discord. I'm always kind of looking through that to see what's in there and what people are kind of looking for. So super happy to see anything in there, even if you're just kind of describing something. Doesn't have to have pictures or anything like that. Yeah, cool. Well, it seems like nobody has any like real specific point clouds. Like point clouds being, yeah, exactly. Pivots are just data. Exactly. Yeah. Point clouds. That's interesting. Point clouds is another interesting topic. What specifically about point clouds are you talking about? Like manipulating those in like a VOP? I think that might be what you're thinking about. I'd be curious about that. Yeah, exactly. Like Vex and stuff like that and VOPs. Yeah. Yeah. Yeah, I'd have to think about what would be a good kind of way to talk about that, because obviously that's that's a pretty dry topic. Not that I don't mind going into dry topics, but yeah, I'd have to think about that. That's an interesting one. Like I said, throw them. Yeah. Yeah. The interesting effects is the part that's tricky. Like, I know conceptually what they do. The interesting effects is is always the tricky part, right? Yeah. No, it's great ideas. I love them. Throw them in the Discord. I'd love to see, what you guys might have, but, yeah, that stuff's all great. Very good. It doesn't seem, like I said, it doesn't seem like anybody really has anything, kind of that they'd want to play around with tonight. These are a little bit more like future ideas and concepts and things like that. So I think what we'll do is I'll start kind of wrapping things up here. Hopefully this cleared up a couple of little issues that we had in this past couple streams. It's bound to happen, I guess, but, it's always nice to make sure that you get some decent information out there so that people are, understanding these concepts and so I'm understanding them better too. Heck. But yeah, again, if you'd like to be, get a part of the Discord server, there's an invite on HoudiniHangout.com. There's a link in the chat there for it. And, you can get more information, about the stream and different locations. We stream on YouTube and Twitch, depending on what is your platform of choice. But there's there's a couple different ways that you can. Oh, and on LinkedIn as well. I almost said InDesign, which is not. I always get. Why do I don't know. Anyways, but I guess we'll just kind of wrap things up there and say, thanks for joining this evening. It was really nice to have everybody chatting along. Lots of fun folks joining in the chat, lots of good questions and comments and things like that. And always appreciate, hearing ideas for future streams. Again, drop those in the Discord server. There's a whole channel just for that. And, I guess, we'll see you, next week. I think next week we'll be doing, we're going to be doing kind of every other week for the, Mops Monday. So next week it would, there comes Tom. I knew you knew we were talking about PDG. Here he comes in from the top rope. Oh, cool. Thanks, Jeff. Yeah, the value clip stuff was one little thing that I missed that made it that in talking to people that were dealing with bigger data sets, it made it clear like, oh, there was one little thing. There's always that one little thing. But anyways, yes, we will. Next week will be just a Wednesday stream, and going to be kind of alternating every other week to do a Mops Monday, just because sometimes doing 2 a week can just be a bit much. So it's nice to kind of give myself lighter weeks. But anyways, thank you all for joining. Thank you for your comments and everything, and everybody come up to Toronto and we'll all have a good chug of maybe Jeff will bring in some maple syrup and we'll all do maple syrup shots. Anyways, bye everybody. Thank you so much for joining, and we'll see you next time. Have a great evening.